HCAM programming is supported by our viewers, thank you, and by Phipps Insurance Agency, representing companies such as MapFree Insurance. Their family-owned independent agency is deeply rooted in the communities they serve and offer time-tested insurance products to fit individual needs. Since 1950, Phipps Insurance specializes in home, auto, business, condo, and renters insurance. Hello, everyone, and welcome to today's edition of HCAM News. I'm HCAM News Director Tom Nappy, here to fill you in with what's happening in Hopkinton. On today's edition of HCAM News, we have extensive coverage of the annual Hopkinton High School Science and Engineering Fair, including interviews with some of the student scientists, the award ceremony, and much more. So without further ado, we take you to the Hopkinton High School 2026 Science and Engineering Fair. The 2026 annual Hopkinton High School Science and Engineering Fair took place in the high school cafeteria and featured over 50 student participants. 12 teams would be selected from the fair to head to the regional competition.
My name is Suchit, and
my name is Saket.
Our project's all about the use of algae to combat with water acidification and toxin removal. Now everybody's talking about climate change and how that's affecting the world. So we wanted to see what is one form of climate change, and we came to be of water acidification.
Yeah, I agree with Suchit over here about how it's a current event kind of
And how long did your project take?
I think 4 or 5 weeks.
For our experiment, we basically diluted vinegar in a 1-to-10 ratio with water, and then we put algae in it and saw the outcome of the thing, and we were hoping for it to neutralize at 7 and bring down the amount of toxins.
My name is Harish.
I'm Lindsay.
I'm Lumen.
We're simulating coastal ecosystems, and we're specifically looking at pH and salinity on calcium carbonate dissolution.
We did this project for about 2 months, and we have noticed some very interesting things about calcium carbonate dissolution.
So basically, the world right now, it's experiencing more and more carbon dioxide emissions in the air and also in the waters. So the carbon dioxide in the waters actually is called ocean acidification, and it's really detrimental towards lots of things, and especially ecosystems and society, as stated up here. And so we were interested to see what kinds of solutions or things that we can do to help increase the pH, because the more acidic the ocean becomes, the more detrimental it is. So one of the main challenges while we were performing our experiment was that when we used these calcium carbonate chips, straight out of the container, they didn't actually dissolve inside the seawater solution that we made. So then we tried adding it directly into vinegar to try to dissolve it first, but it did nothing. And then we tried boiling the vinegar and then dissolving the calcium carbonate chips there, also did nothing, but just created really bad smells that we used masks to help avoid the smells. And then finally, we used a mortar and pestle to ground up the calcium carbonate to increase the surface area, so then it would be more probable for the powder to mix in and have a chemical reaction with the saltwater solution. And it actually worked.
Another challenge that we also had was time constraints, and that is really important for our project because our project does involve a bit more time as we need the calcium carbonate to be dissolving. And so time constraint being that we started the project a bit later than we hoped, and if we started it a bit earlier, then we probably would have gotten some better results.
I'm Sahaj Pogula.
And I'm Arjun Mehta. And our project is the effect of a weak electrical field on a drug like molecular transport across a model of blood-brain barrier. The before we start talking about science, I want to talk about why this project really matters to us both. Both our families struggle from brain diseases like Parkinson's and Alzheimer's. This doesn't just affect one person, it affects entire families, physically, financially, and emotionally. When we were looking for a solution, we found out that the main problem is just the drug delivery in general. Either it's not efficient enough or it's severely painful for the patient, like through intrathecal or IV or IT, because it has to be injected right through the skull and into the brain tissue.
Our project models how a weak electrical field could transport a molecule through the blood-brain barrier. We modeled the molecular transport by using an agarose gel, as you can see over here, and we placed a small dialysis membrane to model the blood-brain barrier. We then placed a small amount of bromophenol blue in these small wells over here to show that to model the drugs. We then place it in the agarose gel container and run the electrophoresis system for a constant amount of time. We research on how a weak electrical field enhances the transport across a blood-brain barrier system.
Because we didn't use real drugs or real brain tissue, we made a physical model that captures the key features of the blood-brain barrier. As you can see there, the agarose gel is meant to represent the bloodstream. The cellulose dialysis membrane is meant to represent the blood-brain barrier. The electrophoresis battery machine is meant to simulate the electric charges. The bromophenol blue dye is meant to simulate the drug because it is visible and charged, and electrophoresis is the system we use to do this.
Thank you.
All right, and just a couple questions for you. So, was the result of your project the way you expected it to be?
Yes, we wanted the result to be increasing in value. So as we increase the voltage, the distance of the dye travel increased. And while we increased the amount of barrier thickness, the transport of the molecules decreased.
Terrific. And how long did you do this project for?
We started our research since July of the summer, and we've taken it from a small experiment to a big experiment using a big battery and electrophoresis chamber. You want to talk about the iterations?
Yeah, so the first iteration of our project really just explored how weak electrical forces acted on a barrier, but this wasn't very consistent or controlled. So our next iteration was this. A few problems we ran into was that our materials didn't come on time, just because of either weather conditions or the seller just didn't ship it on time. In order to solve this, we reached out to Boston Scientific and Thermo Fisher, and luckily they had what we needed. The second problem we ran into was, as we were trying to cut our agarose gel to put the membrane in, since the agarose gel is very delicate, we had to be very careful. But in order to bypass this, we used molten agarose gel of the same consistency and poured it into the spots where there were air bubbles. And that worked perfectly because it reduced leakage, and that's how we got to this project.
I'm Joe Stevanto.
I'm Advait Patala.
And I'm Preya Karthik.
So our project's documenting light pollution. It's documenting like how everyday surfaces can impact light pollution in a lot of different ways, and how rough surfaces tend to be more harmful for the environment than smooth surfaces. That's the gist of it. Well, we did a little experiment. We took a bunch of different surfaces, we shone a light on them, we measured it from a bunch of different angles, and what we found was that these rougher surfaces, they shone a lot more light upwards, while these smoother surfaces, it was a lot down. It was going like towards the floor.
So in total, I would say we took about 3 to 4 months researching and experimenting to find the values. And this took place in a basement with limited objects. So I feel like we made a lot of progress.
Excellent. And was there any obstacles along the way that you had to work over?
Yeah. So of course we did this indoors. So at first our research and our experimenting wasn't as accurate because if we did this outdoors, there are like many conditions like weather, like rain, snow, and all those that can affect it. And ours is in one controlled environment. So yeah.
I want to say that these two live right next to each other. I live 15 minutes away from them by car. So it was kind of annoying to meet together, but we made it work.
There were definitely a few issues for sure. Like he said, we had to meet together, and we all lived in somewhat different locations. But also this was a topic that we thought was a little bit more complicated. It involved a lot of math, so we had to do a lot of calculating and researching to understand and get the data we thought was right for our project.
My name's Prisha. My name's Sia. My name's Navia. Our project is about malnutrition and how malnutrition affects underprivileged countries around the world. So we basically chose 6 specific flowers. As you can see here, the moringa, okra, pumpkin, cowpea, green pea, and soya. And we basically tested these flowers on fruit flies. And if any of you want to carry it. We chose local sources, and we depended on the cost and all such constants, so we can test if we can help anyone out there in the world.
We used a lot of different tests to gather the neurological functions like memory, motor function to get the best conclusion. There were a total of 5 tests that we did. One was monitoring the death rate of their if kept for 2 weeks. One was using a stereoscope or similar to a microscope to find the neuronal spikes of the fruit flies and the strength of those neuronal spikes. We also used an exploration test and also a climbing test to find those results, to have our conclusion of green pea flower being the best.
Initially, our hypothesis was that the moringa flower would be the best one, and it would be the one which we would choose, and it would be the best for the fruit flies. But the green pea flower was the one which was the best for the flies, and this was based off all the tests that she mentioned. And it's also the lowest cost for the underprivileged countries, and it's locally sourced.
We've been working on the testing for about 3 weeks, but we have about 3 days of data for the weeks, and we've been working on this project since about September, August.
I'm Sana Kandasamy.
I'm Pranika Rai.
Our project is testing different diets based on the ratio of carbohydrates to proteins in planarian and their effects on planarian regeneration. And planarians are these flatworms that are capable of regenerating their limbs.
So a bit of our research was seeing how the different diets in the protein and carbohydrates and how they can affect how many days it takes for them to fully regrow a limb. And our experiment was we had different ratios of our proteins and carbohydrates, where we had 100% protein and a 0% carbohydrate, and then we had 75-25, 50-50, 25-75, and 0 and 100. And we saw how long, they had the different days, and we cut off their limbs, and after they ate it, we saw how long it took for them to fully regrow their head, which we cut off.
Was the result what you expected it to be?
Yes, we actually hypothesized that the 75% protein to 25% carbohydrate group would ultimately be the fastest regeneration out of these 5 groups. And we thought this because proteins are the building blocks to life, but then without a little bit of energy to utilize that building block to its max potential, it's not going to work out very well. So that's why we hypothesized that. And with our graph and our research, that ended up being the conclusion as well.
I'm Jacob.
I'm Rudra.
And I'm Yuli.
So basically our project is kind of a way that we can detect stress in plants before they actually start suffering from the symptoms. And so kind of what we did was we looked at the electrical signals generated, the action potentials generated because of specific stressors, and we used them to kind of correlate them with the stress in plants and see how we can predict when those appear in plants before they actually start being physiologically affected.
We spent probably a year on this project, and in the end we were able to get pretty accurate with our model to identify whether or not a plant was stressed or not, depending on what electrical signal we picked up from them. I think we went through probably hundreds of plants. Went to tomato plants, pothos plants. We had this little makeshift greenhouse in the basement, and we're just going through iterations after iterations to improve our signaling.
And is this your first science engineering fair?
For Yuli and I, this is our second. We also participated in freshman year, but it's Rudra's first.
I'm Jaya.
I'm Vanya.
So our project is to see if AI can identify the difference between metastatic and non-metastatic breast cancer, and we've used code to help us with the process. We were able to identify the top 10 genes that were different between metastatic and non-metastatic breast cancer patients, and to see if a certain gene can help someone survive or not.
I think coding was probably the hardest part because we were just learning coding, and as freshmen it's a bit more tougher. So I think coding was what took us most of the time and was the hardest obstacle.
My name's Smarin.
My name is Ankit.
My name's Nihal.
Yeah, so our project is about converting kinetic energy and motion into electrical energy. So what we do is we got inspiration for this project from Ankit's dad when he was complaining about the electrical bill. This sparked the idea for us to create a renewable and cheaper energy option that we could that could be used in various places at multiple times.
So we used piezoelectric sensors so that whenever we step on the board, the sensors, because of the crystalline structure, they will create an electrical charge, which can be used to either store or use energy.
We had to use rectifiers to convert the piezoelectric sensors from an AC current to DC, and we used that to power an LED light bulb.
We were able to light up the LEDs with pressure, but it wasn't as cost effective as we wanted it to be. But after reflecting upon it, we definitely think we could make it more cost effective.
One of the main obstacles we ran into were the wires being too short and it also not being color coded. So we had random yellow wires throughout the entire project. So we had to keep on flipping the board to figure out which light is positive and which is negative. So because of that, we kind of wasted time into color coding the wires when it would be useful if we did that the first time.
This all took, the wiring probably took 3 or 4 weeks, and then putting all of it together and connecting it to the light also took another 3 or 4 weeks.
Hi, I'm Roma.
I'm Ananya.
So our project is on the regenerative effect of cranberry juice for radish and lettuce seeds.
We did another project in 9th grade where we found that cranberry juice is actually really good at inhibiting biofilms, which is a type of bacteria that's really hard to kill. So we're trying to see what other properties the cranberry juice could have.
So we discovered that 2 and 3% solutions of cranberry juice in distilled water, the cranberry juice was actually able to promote cell regeneration.
This is actually our second experiment. Our first experiment was we tried to do the same thing but with planaria, but then all the planaria ended up apoptosing, so we had to switch to the seeds, and the seeds did have the outcome we were looking for. I think because this time we had to do it at home, and then 9th grade we could do it at school. It was a lot easier in 9th grade because we also had more guidance and more available material, so this year it was a little harder.
Excellent. How long did this take you?
It took a few months, starting in October, so.
I'm Devin.
I'm Trinisha. I'm Hari.
So our prototype is an infection detection Band-Aid. We call it Sense and Defense. So we basically take the pH and the temperature of the wound, and if there's certain changes compared to baseline or studies, then we can see that there's an infection or changes and stuff like that, which can lead to infection.
Yeah, so for a procedure, we had to
use a lot of tubing and sensors like an ESP32 board sensor. And we had to make a code using C++, which took a lot of trial and error, but we were able to get it to work. Based on that, we tested it using baker's yeast, since bacteria wasn't allowed to be used during our science fair project. And we got really accurate measurements when we tested it with more professional sensors. Our pH level was 0.10 error, and then our temperature was a 2.06 error, showing that it was really significantly accurate for us.
All right, so did the results come out as you would expect, or was there anything surprising about what you found out?
Actually, we were thinking, so our limited false positives was supposed to be 5% or less, and we got a 1.01% error and a 2.06% error. So like, yeah, we expected it to work. So yeah.
Excellent. And how long did you work on this project for?
So took us really long actually. We started in September, started with background research and looking at sites, research papers, and then we started to build it in mid-November and then December, and then we did our notebooks. Yeah, it was a really long process. We had to code the ESP32 using C++.
Yeah, and we also faced a lot of challenges because when we created our prototype, there were a lot of different errors that we faced, our 3D printed box wasn't the right dimension, so we had to reprint it all. And then the code sometimes did not work, so we had to keep debugging it and seeing if we could fix them.
We are very proud of our students. They always impress us, and we hear from judges, family members, and community members how impressive it is when they come to this cafeteria to learn about the research that they've done in less than a year. On top of being a high school student and on top of all the extracurriculars that they're involved in. So there was a lot of diverse projects that had to do with AI, experimental projects where students were growing plants, neurological projects where students were testing activity in the brain of a fruit fly. And I think what always impresses me is that students are pursuing an interest in something that they might not be able to pursue in a traditional science course, and they get to pursue that interest outside of their science course on their own, and it's amazing to see how that interest grows into a science fair project.
All right, and 12 teams are going to the regionals.
Yes, 12 teams.
Where is the regional?
The regional fair is at WPI on March 6th, and they'll be presenting their work with other schools in our region, mostly nearby. And then if they qualify, they can present at the state, and that presentation is in April at Gillette Stadium, I believe, but I'd have to double check.
All right, and with all these great projects today, it couldn't have been easy to just choose 12.
No, it was not easy to choose 12 to go to regionals. The judges said that they were very impressed by all of our projects, and they, like Kristen mentioned, were impressed by the fact that these projects were rooted in an interest that they had, and they were really well done, and that the students were able to sometimes choose something simple but do it really well and understand all of the complex chemistry or physics or environmental science related to their projects. So we're very proud of them and very excited about their opportunity to present at the regional fair coming up in March.
HCAM is supported by our viewers. Thank you. And by the Hopkinton Independent newspaper and online news site. The newspaper reaches 100% of the homes and businesses in town, and the website is updated daily with exclusive Hopkinton content. Readers can receive a daily newsletter and breaking news alerts via email.
On Sunday, February 1st, at the Boston Sports Institute in Wellesley, the TVL Championship swim meet took place. The Hopkinton girls placed 7th, the Hiller boys finished 4th. Coming in first place was the Dover Sherborne girls team and the Westwood boys team. On Tuesday, February 3rd, Hiller boys basketball hosted Holliston in a crucial TVL Large matchup. It was a back and forth first quarter. Wally Henneberry and myself, Tom Nappy, on the call.
Holliston's second.
Yeah, I think what the foul was is they're saying McHugh pushed him out.
Right.
Finelli, long three, got it! Rocco Spinelli. Allison having a tough time trying to find a way into the interior. They launch a three, and it's good. Jack McDonald, the junior, strikes. They like his talent. He has really came through big in some of these games. A three ball there. Cal Leverone. Peavy gets it over to McNally.
Yeah, high pass. McNally really had to go upstairs to get that one.
McNally trying to go around the defender, and he will get a bucket.
Yeah, hard-earned bucket right there in the post. A little up and down, a little fake, a little turnaround, get using everything in his arsenal to get himself 2 points.
I don't know, is that a travel wall?
Yeah, it would have been.
Elstrom Hall knocks it down.
Little bunny step there.
That's all right. You get away with one once in a while. But what a nice bucket by Elstrom Hall at the buzzer. Yes! Robbie Howell lays it in. It's time to tell you about some of the happenings in town you should know about. Upcoming Hopkinton Hiller Athletics. We have a ton of great action coming up for you, including on Thursday, February 12th, we'll have the Hiller Alpine Ski Fun Run. That starts at about 6:30. And we'll also have Hiller Varsity Girls Basketball as they host Norwood. Then on Friday, we have Friday Night Hockey, a doubleheader. It starts at 5 p.m. with Hiller Girls Co-op against Norwood. Then at 7 p.m., we'll have Hiller Boys Hockey as they take on Lincoln Sudbury. For streaming information, head over to our website, hcam.tv. The Marathon Fund Committee is awarding 8 $1,500 scholarships to graduating high school seniors who are residents of Hopkinton. Applications are available in the town manager's office. For more information, you can contact Town Hall or stop by. And we also have information on our website, hcam.tv. Need help paying property taxes? You can apply by February 20th to the Hopkinton Tax Relief Fund. You can find more information at the town website, hopkintonma.gov. Upcoming town government meetings include on Tuesday, February 17th. We'll have the Elementary School Building Committee at 6 p.m. To view all upcoming town government meetings, head over to hcam.tv/gov, or for more information, you can head over to hopkintonma.gov. Believe it or not, we are out of time for this edition of HCAM News, but don't worry, next Wednesday at 6:30 p.m., we'll be back. For everyone at HCAM, I'm Tom Nappy. As always, we thank you for watching. Take care, enjoy the rest of your day, and we'll talk to you again soon. Goodbye, everybody.